Second question. We just proved these two triangles are congruent with each other. Okay. Thereafter, next question. Join SR and show SR equals to AB. Join SR. Okay. We have already connected. The pre-existing diagram would be something like this. I already connected these. So here, join SR and show SR equals to AB. That's the thing we are going to show here. Okay, SR equals to AB. Okay. To show that, we can use the parallelogram theorem. We already know that according to the data, these two are equal. These two are same. So first I'll write AS equals to AS parallel to BR because previously they were given the data. And thereafter, we just showed these two triangles are congruent. No, if these two triangles are congruent, we can derive this side which equals to this side. If these two triangles are congruent only, the corresponding similar elements are equal with each other. Like that, we can show these AS equals to BR. We know that in a parallelogram, if a pair of opposite sides are equal and parallel, that shape is a parallelogram. If a quadrilateral has a pair of equal and parallel sides, that is a parallelogram. We don't know. Earlier also I mentioned that this is only a quadrilateral. We don't know whether this is a parallelogram or rhombus. So now we derived according to the parallelism in previous section. Okay, because here you can write already proved. Because if these two triangles are congruent with each other, this side equals to this side, this one equals to this one equals to this. Likewise, we just denoted this equals to this. So, if a quadrilateral has a pair of equal and parallel sides, that is a parallelogram. Okay, likewise, you can give your reason. But this is not our question. Our question is to show this one and this one are equal. Connect S and R and show SR equals to AB. Now we derived this is a parallelogram. Now we can directly show therefore SR equals to AB because opposite sides of a parallelogram. Are equal. No, likewise, therefore SR equals to AB. We already derived this is a parallelogram. So opposite sides of a parallelogram. Likewise, you can give your reason. To prove this, you will get 3 mark. Not a difficult one, very easy. First, these are parallel. Thereafter, these are equal. So, if a quadrilateral has a pair of equal and parallel side, that's a parallelogram. Therefore, AB equals to S, opposite sides of parallelogram. Here, let's write the parallelogram's name. ABRS. Parallelogram ABRS. This is the way you should show the reasons. Okay, last question. Show that area of ABRS, that means area of this parallelogram, equals to A times of ACX. Okay, let's connect this ACX first. Okay, ACX means this small triangle. We already know the parallelism between those lines, so we can use that one as well. Okay, these are parallel and these are also parallel with each other, and thereafter we have to show the reason. Okay, reason. First of all, to find area of a triangle, we have to use half into base into perpendicular height. Area of a what we call area of a parallelogram that is base into height. Okay, base into perpendicular height. That's the way we need to show area. First of all, I'll consider this length. Okay, this small length as x. Okay, small length as x. That's the thing first I used. If not, we cannot show this. No, that's why we are using some variables to correlate with. So thereafter, if this one is x, okay, if this length is x, this total length, that would be 2x. This AB is 2x because we know that C is the midpoint of AB. Likewise, we need half into base into perpendicular height. Okay, perpendicular height of this, I'll conclude. Okay, in your diagram, you should draw a new diagram and show perpendicular height is like this, y. Okay, perpendicular height of this small triangle ACX. Okay, ACX. Since it is a obtuse triangle, perpendicular height should be located outside of the triangle. If it is a acute triangle, perpendicular height is inside. If it is a right triangle, perpendicular height is one side. If it is obtuse triangle, perpendicular length is located outside of the triangle. We know that. If this one is y, we know that we can use midpoint theorem here. So if this is y, the total length between this and this, we know that this is a parallelogram. In parallelogram, when these two lines are intersect, this would be the intersection of diagonal from the diagonal to one side, which is y. So likewise here also, here to here also, the length is y. I'll conclude this length also equals to y. Okay, this length is also equals to y. I'll denote it. Okay, this one also y. Similarly, this one also y. Thereafter, let's write the relationships to find area. Okay, triangle ACX, area of triangle ACX, half into base. Base of this ACX is x. Okay, x. Okay, this one is the one. Here I'll write here. This one is x, so this total would be 2x. Half into the base x into perpendicular height is y. So we have a relationships to if we know x and y quantities, we can find triangle's area. So xy divided by 2. This is the equation. Then let's write the equation to find area of this parallelogram. Okay, parallelogram ABRS. Here you should multiply base into perpendicular height, not half. Base is 2x multiplied with perpendicular height. Here we conclude from the intersection of this diagonal to one side, which is y. So similarly here to here also y. So total perpendicular height between these parallel sides, which is equals to y plus y, 2y. So 4xy, this is the equation related with x and y to find area of this parallelogram ABRS. Next, let's write. Next, what do we need to show? We need to show the relationship between them is equals to x. First, I am going to divide ABRS, area of parallelogram ABRS divided by area of triangle ACX, which is equals to this one should be divided by this one. Think about the simultaneous equation likewise. So here 4xy should be divided by xy divided by 2. xy divided by 2. So this xy and xy can be simplified. Thereafter the dividend will be a multiplicand. So area of ABRS, which is equals to 4 times 2, which is 8, ACX, 8 times area of this triangle ACX. I'll explain what happened over here. I just denoted some variables, otherwise we cannot find this. No, that's why I used some variable. In your diagram, you should denote them. Thereafter, I found a relationship to find triangle ACX area and ABRX area. So then I divided this one by this one. So 4xy divided by xy divided by 2. So 4 divided by half. Divided by half means 0.5. 4 divided by 0.5, that will give you 8. 8 times area of ACX.